right? Do you still remember what eigenvalues we got? We get, let's just type in the eigen of this matrix. 3 minus 0.5 and 1, 0, 0, 0, 1, 0. We get minus 2.668 and 1 and 0.1. Actually, last time we focused on this one because that's actually creating the instability, right? The eigenvalue that has the largest magnitude creates the instability. And I will just make a note here that we'll see later. Another eigenvalue is exactly equal to 1. Okay, we're going to see it's not a coincidence. So let's actually start looking back on why are the two schemes we have already studied, the previous two schemes, forward Euler and midpoint, how are they stable, right? We have solved the equations successfully with these two methods. So let's see if we apply the same analysis to forward Euler. And again, we are solving the equation du dt equal to 0, right? Using forward Euler. That would be what? U of k plus 1 equal to what? Come on. If we apply forward Euler to solve du dt equal to 0, u of k plus 1 would be equal to uk, right? Okay, so I mean forward Euler is uk plus 1 equal to uk plus delta t times the right hand side, which is 0, right? So uk equal to uk plus 1 equal to uk. So if we apply the same matrix analysis, how big of a matrix do we get? 1 by 1, right? Because it is already an iteration that depends only on the previous equation. So the matrix is actually just what? 1, right? So if we perform an eigenvalue analysis, we would be doing this. We get 1, exactly equal to 1. Again, we have eigenvalue exactly equal to 1. Okay? So midpoint. Let's do this with midpoint. So we again solve the equation du dt equal to 0 with midpoint. What do we get? What scheme do we get? U of k plus 1 equal to what? What is midpoint? Yeah, look at your notes or think of the midpoint as discretizing du dt as what? uk plus 1 minus uk minus 1 divided by 2 delta t, right? If that is equal to 0, how do we write the scheme? What is uk plus 1 equal to? uk minus 1, yes, thank you. So that would be midpoint. How do you write it in matrix form? How big of a matrix do we get in this case? So 2 by 2, yes. I mean, it looks there is only one term, but it's actually not just the previous term. It's the two iterations ahead. So we would still have to write down the iteration as uk plus 1 and uk equal to a matrix, and please help me figure out what the matrix is, times uk and uk minus 1. Now what is the matrix? Yes? 0, 1, 0, 0. 0, 1, 1, 0, yes. uk is equal to uk, right? Okay, so we have this matrix, and now let's do eigenvalue analysis. 2, 0, 1, 1, 0. We get minus 1 and 1. Right, so this shows us both forward Euler and midpoint do not have eigenvalues whose magnitude is greater than 1. Therefore, both of these schemes are able to solve the equation du dt equal to 0 with no problem. Right, so this is really the most basic requirement for a numerical scheme, right? You should be able to solve du dt equal to 0, right, with no problem, even though if you have a 10 to the minus 300 error in the beginning. Okay,